Hey everyone, let's solve vertical order traversal of a binary tree. Given the root of a binary tree, calculate the vertical order traversal of the binary tree. For each node at position row call, its left and right children will be at position row plus one, call minus one, right? And the other one is going to be the right is going to be at row plus one and at call plus one respectively. The root of the tree is at 0, comma 0, right? So the vertical order traversal of a binary tree is the list of the top two bottom ordering for each column index, starting from the leftmost column and ending on the rightmost column, right? So there may be multiple nodes in the same row and same column. In such cases, sort the nodes by their values, right? So return the vertical order traversal of the binary tree. Let's take the first example. As you can see, the root node is going to be as row 0, 0, right? So whenever we move to the left, as you can see, the column is decremented by 1, right? It's going to be negative 149. And whenever we move to the right, the column is going to be increment by 1 is going to be 1, right? And whenever we move to the left, as you can see, it's going to be 1 is going to be decrement by 1 is going to be 0. And whenever we move to the right, it's going to be incremented by 1. So let's take the next example, right? So in the next example, as you can see, the root is going to be at this position, and the nodes are the same column. Let's say, for example, in this case, we have three nodes at the same column, right? So we have to sort them whenever they are in the same column in the row, right? So 1 is the first one, and 5 is the next, and 6 is going to be the last. So this answer for column 0, the nodes are going to be in sorted order, so they are going to be in this way. So to solve this problem, what we are going to use is BFS, right? We have to traverse the node in level wise, right? So we have to use BFS, right? Level order traversal, right? So we start from the first level, right? So this is going to be the first level. The next level is going to be this one, and the last level is going to be this. So when we start from the first level, so we have node one with its respective column is going to be 0, right? So we add it to the queue, right? BFS uses queue, right? So to keep track, we use the node to trap the nodes in its respective column. We use queue, and we add this a pair of these valves, right? So as you can see, the node is going to be on 1 and the column is going to be 0. So we need to have a kind of temporary dictionary to track the the nodes in a respective code. We need to have a kind of dictionary for each level. So let's say it's T. So for column 0, we're going to have in the first level, we're going to have how many we have only one element, right? It's going to be 1, and we iterate over this dictionary and sort the values for each respective column. So for 0, we're going to have only this one, so it's going to be sorted, and it's going to be an array with only one element. So we also need to have a global dictionary, so to keep track all the sorted the columns with their respective sorted values, right? For 0, we're going to have only 1, right? It's going to be this one. So in the next level, we are going to have these two nodes. So what are the columns, right? For this case, the columns are just -1 and 1, right? So for -1, what we have is 2, right? And for column 1, we have 3. So we have 3 right here. So the dictionary is going to be this one. So we iterate over this dictionary and then sort the values for each respective column. So as you can see, since they have only one element, we can just add them to our global, right? So -1 have only it's going to be 2, and the other one is going to be one element, right? It's going to be have only 3. So the next one is going to be the last level, right? So for the last level, what we have is So the dictionary, temporary dictionary, is going to be, we iterate over all the nodes in this level. So -2 has only 4. This column has only 4. And the other one is going to be 0 is going to have two elements, right? 5 and 6. We're going to have 5 and comma 6. We have two elements for this case. And the last column is going to be 2. Is going to have only 7, right? We have 7 here. So it's going to be 7 here. So we iterate over this temporary dictionary, then level-wise dictionary, then we sort the vals for this, for all of them. So for -2, we have only 4, right? And but for 0, as you can see, we have two elements. Then we sort them. It's going to be 5 and 6 when we sort them, and we have to extend the global this 0, right? So when we extend this, it's going to be for 0, we're going to have 1 and 1 6 1 5 1 5 6, right? So it's going to be this one. So the answer is going to be 156 for this case. So for 2, it's going to be just 7, right? The answer is going to be 7. So as you can see, the columns are not sorted, right? So we have to sort them, right? So we have to sort the keys first. So the sorted key is going to be just -2 is going to be the first one, and -1 is the next, 0 and 1 and 2, right? So we can just iterate over these sorted keys or sorted columns, and we can just collect the values, right, for each respective column, right? So for -1, we have 4, right? We're going to have 4, and for -1 is we're going to have 2, an array of 2, and for 0 we're going to have an array of 1, 5, and 6. 1, 5, and 6. But for 1 we're going to have for 1 we only have 3, and for the last is going to be 7, right? So the answer is going to be an array of these arrays. So the time complexity is going to be n log n, since we are going to sort them, and the space is going to be just of n, just the number of nodes in this tree. So let's go to the implementation, right? First, we need to have call table, just the default dict of list, and we need to have a queue. They say a double double-ended queue. Then we have to add the root with the respective call is going to be 0. Then we iterate over, so while I'm in queue, while this is not empty, then we need to have the length of the queue. We have to iterate over each in range of n, right? We have to iterate over each level. Then the node is getting the call just is queue dot pop the left one. Then what we need to do is just, let's say, let's going to have our level counter, or just we can just say temp or level counter. Let's call it level counter is going to be default dict, and it's going to be a list. Then for level counter, what we need to do is of call dot append the node dot val. We have, for each call, we have to add its respective the node val, right? So if the node we have popped has a left, then q dot append node dot left, and the column is going to be decrement by 1. It's going to be, since we are moving to the left, if the node has a right, what we need to do is q.append node dot right and call +1. Yeah, this is the case. So once we have done, we can just iterate over each call, let's say in level counter. Just we're just counting the columns, the nodes in a certain column. Then what we are going to do is just call table, let's say at a certain call. For that certain call, we can just append, or we can just extend. Instead of append, we have to extend. The extend, we level counter, we have to sort the nodes in a certain call. So column, so we can just use sorted, right? It's going to return an iterable. So we can just do this, and once we have done this, we can just return an array of call table. Let's say call table, we have to sort the keys, the columns first, right? So of, let's say, call in for call in call table dot keys. This has to be sorted. The keys has to be sorted. So sorted, as you can see, this is going to be iterable. So it has to return this thing, right? Then so yeah, and just we can the time is going to be, as you can see, just the time is going to be, since we are sorting the keys, the time is going to be analog again for it's going to be since this one is going to be just we are going to see all the nodes once. So, and it's just we have two loops, right? But it's not going to be just it's not going to be just we are seeing each element once, so it's not going to be anytime is n, right? But sorting in this way, this is not that much. It's going to be analog again for all over time complexity, but the space is only the number of nodes in the number of nodes in the tree. So let's test it. So as you can see, passed for all of them. So let's submit it if it works for all of the given test cases in this problem. So as you can see, passed for all of them. If you like this video, please subscribe.